Good evening, children. Good evening.
Good evening.
Good evening, children. Yeah, I'd ask you to take screenshots and complete some of them. So we've till here we understood in the last class. This one I told you that we had already worked this earlier. This was already explained. So this is done. Now I have to explain from here. Only some 2, 3 I'd asked you to complete, not much. Okay, so here we need to prove that sin A plus cosecant A the whole square plus cos A plus secant A the whole square is equal to 7 tan square A plus cot square A. All right. So you can use the identity A plus B the whole square is equal to A square. See the LHS. This is the LHS. Use the identity A plus B the whole square is A square plus B square plus 2AB. So sin square A plus cosecant square A plus 2 sin A cosecant A. And then here again, A plus B the whole square is A square cos square A plus B square secant square A plus 2AB plus 2 cos A secant A. So the first step is we expand using the identity A plus B the whole square. Next, sin square A, cosecant square A. We know that sin A and cosecant A are reciprocal ratios. Sin A and cosecant A are reciprocal ratios. So see here, 2 sin A into cosecant A can be written as 1 by sin A. Or you can write cosecant A as it is, and you can write sin A as 1 by cosecant A. So they get cancelled. Sin A into cosecant A is 1. Sin A, the product of a ratio, a trigonometric ratio, and its reciprocal is 1. So like 5 into 1 by 5 is 1. The product of a number and its reciprocal is 1. So here sin A, the ratio sin A, this is its reciprocal cosecant A. So obviously this product is 1. Sin A into cosecant A, the product of a ratio and its reciprocal is 1. We know that, but you will have to present that. So sin A as it is and cosecant A is 1 by sin A. So they get cancelled like this. Cos square A, secant square A as it is. Here cos A, secant A is 1 by cos A. So gets cancelled. Or you can write secant A as it is and write cos A as 1 by secant A. So secant A will get cancelled. Okay, so next step gives you sin square A plus cosecant square A, sin square A plus cosecant square A plus 2. This gets cancelled. So 2 into 1 is 2 plus 2. Plus cos square A plus secant square A plus cos square A plus secant square A. Again, this gets cancelled plus 2 plus 2. Now look at the RHS. So far we were just able to work because we started with the identity A plus B the whole square is equal to A square plus B square plus 2AB. See, we did that using the identity. We did this step using the identity. And then next step we knew we had to write the reciprocals and cancel. So this also just followed. And after this, we have the step. So till here, we started using the identity. So it brings us till this step. Now after this, what? We don't know. Look at the LHS. Sorry, look at the RHS. See the ratios in the RHS. 7 tan square A, cot square A, tan square A and cot square A. 7 plus tan square A plus cot square A. All right. Now let's continue with what we have. So we know that you can see a sin square A here and a cos square A here. We know that sin square A plus cos square A is 1. So let's group that. Sin square A plus cos square A. Because sin square A plus cos square A is 1, let's group that. Sin square A plus cos square A. Then what else we have? We have cosecant square A, we have secant square A, and 2 plus 2 is 4. 2 plus 2 is 4. Okay, so this also nothing like difficult. We grouped sin square A plus cos square A. And then we wrote the remaining cosecant square A plus secant square A. 2 plus 2 is 4. Okay. Now, what next? Sin square A plus cos square A is 1. Now, since we don't want now what are the other ratios? See, this is going to become 1. Sin square A plus cos square A is going to become 1. Okay. Then this is 4. Now we have cosecant square A and secant square A, but we don't want cosecant and secant. We want tan and cot instead. So what we do using the identity, we know that cosecant square A is 1 plus cot square A. Cosecant square A is equal to 1 plus cot square A. And secant square A is 1 plus tan square A. Identity. Cosecant square A minus cot square A is 1. Cot square A is 1. So from this we have cosecant square A is equal to 1 plus cot square A. Similarly, secant square A minus tan square A is equal to 1. So from the secant square A is equal to 1 plus tan square A. 1 plus tan square A. So instead of cosecant square A, we write 1 plus cot square A, secant square A as 1 plus tan square A. So like that, we have introduced cot and tan, which is in the RHS. So this becomes 1. This one is 1. And this we don't want cosecant square A. So we write it as 1 plus cot square A. Cot square A. And we don't want secant square A. So we instead write it as 1 plus tan square A. Tan square A. And then this plus 4. Plus 4. Now you can see 1 plus 1, 2. 2 plus 1, 3. 3 plus 4, 7. 7. Plus cot square A plus tan square A. That's how it will happen when you open up the bracket. 1 plus 1, 2, 3. 3 plus 4, 7. Cot square A, tan square A is equal to the RHS. Hence proved. Very simple and important. Okay. So this is the next one. So we have cosecant A minus sin A into secant A minus cos A is equal to 1 by tan A plus cot A. See it, take up the LHS. Take up the LHS. Cosecant A is nothing but 1 by sin A minus sin A minus sin A into secant A is 1 by cos A minus cos A. When you have other ratios, change it to sin and cos. So cosecant A is 1 by sin A and secant A is 1 by cos A. So once you write this, what is the next step? Common denominator, sin A. So 1 minus sin square A in the first bracket. And in the second bracket, cos A is the common denominator and we have 1 minus cos square A. Now we know that 1 minus sin square A is cos square A. 1 minus sin square A because sin square A plus cos square A is 1. 1 minus sin square A is cos square A by sin A into what is 1 minus cos square A? Sin square A, identity. Sin square A plus cos square A is equal to 1 is the identity. Sin square A plus cos square A is equal to 1. So sin square A is equal to 1 minus cos square A. Cos square A is equal to 1 minus sin square A. So 1 minus sin square A is cos square A. 1 minus cos square A is sin square A divided by cos A. Now you can cancel this cos A, cos square A. So there's one cos A here, sin A, sin square A. There's one sin A here, sin A here. So we get sin A cos A. We get sin A cos A. The LHS is sin A cos A, but the RHS is 1 by tan A plus cot A. So we have not got, and you know that the LHS is so simple, sin A cos A. Sin A cos A. Nothing much can be done with this beyond this. Upon working the LHS, we get sin A cos A. And sin A cos A is so simple. What do we do with that? So we stop there. We take up the RHS. We'll work the RHS and we should get the same thing, sin A cos A. So LHS is equal to RHS. LHS we got sin A cos A. RHS you should work and you should get the same thing, sin A cos A. So LHS is equal to RHS. So see, when you just start like this, you know, when you just start cosecant is 1 by sin, secant is 1 by cos. That is what we did. So once you write that, common denominator. Okay, then identity 1 minus sin square A is cos square A. 1 minus cos square A is sin square A. Then you can simplify. You can cancel out, simplify. And you get sin A cos. Now let's work the RHS. Let's work the RHS. RHS is 1 by tan A plus cot A. What is tan A? Sin A by cos A. Because what is that we got in the LHS? Sin A cos A. So what is tan? Sin A by cos A. And there's a rule also. When you have other ratios, change it to sin and cos. So cot A is cos A by sin A. Cos A by sin A. So LCM 1 by common denominator sin A cos A. Sin A cos A is the common denominator. And in the numerator, you will have sin square A. Sin square A plus cos square A. Sin square A plus cos square A. Tan A is sin A by cos A. Cot A is cos A by sin A. Common denominator sin A cos A. And in the numerator, you will get sine square A plus cos square A. So is equal to 1 by sine square A plus cos square A is 1 by sine A cos A by sine A cos A. 1 by, why is this 1? Because sine square A plus cos square A is 1. So 1 by sine A cos A. Remember, this is the numerator. And this full thing is the denominator. Because see, this is the denominator. This is the denominator. This is the denominator. So it's like 1 divided by 1 by sine A cos A. 1 divided by, this is the numerator. 1 divided by, this is the denominator. 1 by sine A cos A. So reciprocal. 1 into reciprocal. Sine A cos A. So you can see that 1 into sine A cos A is nothing but sine A cos A, which is the, okay, 1 into sine A cos A, which is sine A cos A. So RHS works to sine A cos A. LHS also, we got sine A cos A. LHS is equal to RHS. So here 1 plus tan square theta by 1 plus cot square theta. You need to prove that it's equal to 1 minus tan theta by 1 minus cot theta, the whole square. I want somebody to explain this. Tell me, what do we do? 1 plus, take up the, what is that, LHS? What is 1 plus tan square theta? What is 1 plus tan square theta? One plus tan square theta.
Sec square theta.
Secant. Or they say sec square theta. I told you I'm not used to that. So secant square theta. Yeah. So this is secant square theta. 1 plus tan square theta, secant square theta divided by, what is 1 plus cot square theta?
Cosecant square theta.
Cosecant square theta. Now what will you do after this? So it's like secant square theta divided by cosecant square theta. Cosecant square theta. Yeah. What is secant square theta? Sine cos. 1 by
Cos square theta.
Yeah, was it Harini?
Yes, ma'am.
Very good. 1 by cos square theta divided by what is cosecant square theta?
1 by sin square theta.
1 by sine square theta. Very good. 1 by sine square theta. Then 1 by cos square theta into what? Into
Sin square theta by 1.
Yeah, so this is nothing but sine square theta by cos square theta. What is sine square theta by cos square theta?
Tan square theta.
Tan square theta. That's all. It's okay. We have not got the RHS. So now we can take the RHS and work. We can now take the RHS and work. All right. So the LHS is 1 plus tan square theta by 1 plus cot square theta. Using the trigonometric identities, 1 plus tan square theta is secant square theta. 1 plus cot square theta is cosecant square theta. That's the first step. Then just write it like this. Secant square theta. Square theta. Secant square theta is 1 by cos square theta, reciprocal ratios, divided by cosecant square theta is 1 by sine square theta. And then you know this one and this and this. So the LHS works to tan square theta. Now let's work the RHS. We should get tan square theta for this also. 1 minus tan theta. I told you if there is tan and cot, you know, you can also write it in tan. You can either convert tan to cot or cot to tan. You can also, you know, like convert both tan and cot to sine and cos. Option 1, whenever there is tan and cot, you know, tan and cot, You can convert cot to tan or tan to cot, or you can write both in terms of sine and cos. Anyways, you'll get the result, the desired result. Now here, since we, what is that we need to get? We need to get tan square theta, right? So maybe you can have it like this itself. You can just start like this. 1 minus tan theta by 1 minus 1 by tan theta, the whole square. Is that okay?
Yes, ma'am.
Yeah. So 1 minus tan theta divided by 1 minus cot theta is 1 by tan theta. Cot theta is 1 by tan theta, the whole square. So we have changed cot to tan, and we are trying to get tan square theta. Desired result is tan square theta. Okay, so what can we do? In the numerator, let's write it as it is. Denominator, we can take, you should just start simplifying. So the numerator, we don't know what to do. So let's work the denominator. At least there's something like you can take the common denominator. So tan theta is a common denominator, and you'll get tan theta minus 1, the whole square. Yes or no?
Yes, ma'am.
Yeah, nothing we have done to the numerator. Denominator is common denominator tan theta. So we get tan theta minus 1 by tan theta. Now, whenever it's like this, because children do get confused as to which one goes to the numerator and which one remains in the denominator. That is why I always include this step. That's why I always include this step. What is that? 1 minus, this is the numerator, 1 minus tan theta. This is the numerator divided by tan theta minus 1 by tan theta. That's why I always write it like this so that, it's easy for me to explain also. So this is the numerator. 1 minus tan theta is a numerator divided by, this is the denominator, tan theta minus 1 by tan theta. That's a denominator, the whole square, the whole square. So now 1 minus tan theta, division becomes multiplication, reciprocal, tan theta divided by tan theta minus 1. But you can write tan theta minus 1 as 1 minus tan theta, 1 minus tan theta by taking a minus outside, the whole square. You know that, see here, 1 minus tan theta as it is, children, division becomes multiplication and reciprocal. So when you take the reciprocal, it's tan theta divided by, it's tan theta minus 1. But you can write tan theta minus 1 as 1 minus tan theta by taking a minus outside. So tan theta minus 1 is nothing but minus of 1 minus tan theta. So now 1 minus tan theta, 1 minus tan theta gets cancelled. 1 minus tan theta, 1 minus tan theta gets cancelled. So we are left with a minus sign here and a tan theta in the numerator. So minus tan theta the whole square. Minus tan theta the whole square. See here, this is cancelled. Minus and tan theta. So minus tan theta the whole square, the whole square. So minus tan theta the whole square is minus tan theta into minus tan theta. Minus into minus plus tan theta into tan theta is tan square theta. So this is what we got in the LHS also. Yeah. So this is what it is. You need to practice this. You have to work. Only then you will get the confidence that you can do it. I think I'm okay. So here I've taken the minus out here, children. That's the only difference. See here, what I've done here is I've written this 1 minus tan theta as minus of tan theta minus 1. Anything, you can change anything. Everything is the same. I've written this 1 minus tan theta as minus of tan theta minus 1. So tan theta minus 1, tan theta minus 1 gets cancelled. So we have a minus here and tan theta. So minus tan theta, the whole square. Minus into minus plus, tan theta, the whole square is tan square theta. You can write anything. You can write tan theta minus 1 as minus of 1 minus tan theta. Or you can write 1 minus tan theta as minus of tan theta minus 1. I've explained why it is. Earlier I've explained this. Now I'm only telling you that A minus B can be written as minus of B minus A. B minus A can be written as minus of A minus B. So with this, we come to the end of exercise 8.4, examples and exercise. Examples before exercise 8.4 and exercise 8.4 from NCERT. So now it's like, you know the chapter. You know kind of 80% of the chapter. Yeah, please write down. If A cos theta plus B sin theta is equal to M and A sin theta minus B cos theta is equal to N, prove that M square plus N square is equal to A square plus B square. Please write down the question. These are extra problems, not an NCERT. Yeah. So I'll tell you the procedure, then I have to explain using the answer slide. So now we are given an expression for M. See here, M. What is M? M is A cos theta plus B sin theta. What is N? N is given by the expression A sin theta minus B cos theta. So we have expressions for M and N. M and N. We have expressions for M and N. All right. We need to prove that M square plus N square. So it's like you'll have to prove that this one square, this is M square, this is N square, this is N square. You'll have to prove that M square plus N square is equal to A square plus B square. See, A and B are here, A and B are here, A and B, no, they're here. You should substitute for M and N. You should prove that M square plus N square is equal to A square plus B square. Please listen. So the LHS, the left-hand side is, see here, the left-hand side is M square plus N square, M square plus N square. So what is M? This one, this is M. So you can see M is substituted here, square, M square plus N. This is N square. That's the first step. Substituting the expressions for M and N is the first step. Next, clearly it's like X plus Y the whole square and X minus Y the whole square. See, if you know the identity, you can use the identity straight away. But, you know, when you use the identity here, there'll be very few steps. So I have really expanded. I'll tell you how to use identity also here. If it is for 1 mark, you can use the identity. You don't have to show the steps, right? So then you can use identity. Now I have expanded here using the formula. What's the formula here? X plus Y the whole square. And here it is X minus Y the whole square or P minus Q the whole square, whatever you call it. So now this is X square, this one square. So when you square this, children, it is not A cos square theta. Please listen. See, what is very important is don't go ahead of me. I keep reminding you about this. Do not go ahead of me. Let's do it together. So square this one. What is it? A cos theta, the whole square. What is that? It's A square cos square theta. You can see it here. A square cos square theta. Then you'll have to square this one. What is it? B sine theta, the whole square, which is B square sine square theta. B square sine square theta. So X plus Y the whole square is X square plus Y square plus 2XY. 2XY. 2 into X into Y. 2 into X. This is X. This is Y into Y. This is Y. So what will you get? 2AB sine theta cos theta. 2AB into sine theta cos theta. See here, 2AB into sine theta cos theta. It's a product everywhere. 2 into A into cos theta into B into sine theta. So 2AB sine theta cos theta. Do the same thing for this one, except that it will be minus 2XY. X square plus Y square minus 2XY because it is X minus Y the whole square. That's the first step. Then you can see here plus 2ab sine theta cos theta minus 2ab sine theta cos theta gets cancelled. Now we have 4 terms. You have 4 terms. So rearrange the terms so that you can take out something common between the first 2 terms and the last 2 terms. That is, you are going to group. It's like factorizing by grouping. So we have 4 terms remaining, children. We have 4 terms remaining. One to see these 2 gets cancelled. These 2 get cancelled. So we have 4 terms remaining. Now I've rearranged the four terms. See what have I done? I want to take out cos square theta common. So I've written this one first. Listen to me. I've written this one first. Then I've written b square cos square theta. This one second. Then I have written this one third. A square. This one and this one fourth. Why have you written like that? Because I want to take out. So between a square cos square theta and b square cos square theta is common. So I've grouped them. And then between a square sine square theta and b square sine square theta is common. You can also group to take out a square and b square common. You can also group in such a way that you take a square and b square common. We'll do that also. So I've grouped like this. Then I've taken out cos square theta common between the first 2 terms. So you will get a square plus b square in the bracket. And between the last 2 terms, sine square theta is common. So you get a square plus b square in the bracket. Then you know how it works. You should write this a square plus b square once here. And then cos square theta plus sine square theta. And you know that this is 1. Cos square theta plus sine square theta is 1. So a square plus b square, which is the RHS. You have to prove that m square plus n square is equal to a square plus b square. You can also group like this, children. See here. You can also group like taking out a square common. Where is a square? There is a square here and there is a square here. So we'll write a square cos square theta plus a square sine square theta. Okay, then there is a b square here and there is b square here also. Okay, so let's write b square sine square theta plus b square cos square theta. So what is the idea here? Here we want to take a square b square common. So in the between the first 2 terms, a square is common. So in the bracket you will get cos square theta plus sine square theta. And between the last 2 terms, what is common? B square is common. So what will you get in the bracket? Sine square theta plus cos square theta. All right. Now we know that cos square theta plus sine square theta is 1. So you will get a square into 1 plus b square into, again, sine square theta plus cos square theta is 1. So a square into 1 plus b square into 1, which is a square plus b square. So you can group to take sine square theta cos square theta common or a square b square common. Whatever is your idea, you arrange according to your idea. Please write down, children. I said we can use the identity, children. Actually, I made a meaning. I said you can use a different identity. I made a mistake in saying that because it's a cos theta and a sine theta here. So I was like thinking of this one. We know this, right? X plus y the whole square plus x minus y the whole square is equal to 2 of x square plus y square. I thought we can use this identity, but I didn't notice this one. This is a cos theta. This is a sine theta. B sine theta, B cos theta. No, this identity cannot be used because it should be x, x, y, 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 y. So please ignore that. If it was like x plus y the whole square plus x minus y the whole square, then you can straight away write 2 of x square plus y square. You know this. And if it is x plus y the whole square minus x minus y the whole square, the identity is 4xy. Well, here you cannot use it because the first terms and the second terms are not the same. They're not the same. This is a cos theta, but this is a sine theta. Yeah, please work this, children. Please let me know once done. Finish writing, children?
Yes, ma'am.
Okay. Wasn't this simple, children? Was it easy to understand? Any questions? Any questions, children? No, ma'am. Okay. All right. Let's do something different. Yeah, let's try this one. We'll do the others. Let's do this now. So again, you have some expressions for m and n. You can see the expression for m given and the expression for n. And we need to prove that this is equal to 2a to the power 2 by 3. See here, m is given by an expression, n is given by another expression. We need to prove that this is equal to 2a to the power 2 by 3. Please write down the question. Please complete the identity. What is it?
A plus B
A plus b the whole cube. And the next one?
minus B
A minus b the whole cube. Very good, Ram. Very good. So we'll be using these two identities while answering this question. You can make a note of it. We have seen this in standard 9. Make a note of it. Or if you know it very well, you don't have to. All right. So since the answer is really lengthy, children, I cannot work it here. I have to use the answer slide. Okay, but I'll tell you how the answer goes. So see here, you need to take up the LHS. This is the LHS. This is the LHS. In the LHS, we'll not work m plus c. We'll work it separately because it's going to be very lengthy. And you know, if you make a mistake, it's so difficult to make out where we have gone wrong. So we'll work it in parts, like we sometimes work as step 1, step 2, step 3, and then in step 4 we do the final answer, the final addition, subtraction, and all that. So we'll do the same thing here. What we'll do is, see, this is the left-hand side. Okay, so first we'll find out m plus n. First we'll find it. We'll first find out m plus n. And then we'll find out m plus n to the power 2 by 3. We'll have that. Next, we'll find out m minus n. Then we'll find out m minus n to the power 2 by 3. Then we'll add the two results and show that it's equal to 2a to the power 2 by 3. So we'll take up the left-hand side. In the left-hand side, we'll not work it at the same, we'll not work this expression all together at the same time. We'll take it up in parts. We'll first take up this one. We'll find m plus n. Then we'll find m plus n to the power 2 by 3. Have that result. Then we'll find m minus n. And we'll find m minus n to the power 2 by 3. Now these two results we'll add because it's plus, we'll add. And that should be equal to 2a to the power 2 by 3. Is the power 2 by 3 for 2 also? The power 2 by 3, is it for 2 also or only for a? The power 2 by 3, is it for both 2 and a or only a? Okay, I have to answer it myself. It's only for a, it's not for 2. It's only for a, it's not for 2. So see here, children. Quickly run through the answer. I'll just tell you how it goes. So see here, you can see m plus n. This is m, this is n. Then this is what you get when you open the bracket. And then you can see that a is common everywhere. Whenever there's a common factor, bring out the common factor. That's a golden rule. Whenever there's a common factor, bring it out. A is common. So here, children, see, this is the first 1 minute. So see here, this is m plus n. So this is m, this is n. Then we've opened the bracket. Then we've just opened the bracket. That's this step. Okay. Then in the next step, before taking a common, I've just rearranged the terms. See, you can see a cubed, sine cubed theta. 3a square b, sine square theta, cos theta, sine theta, cos square theta, cos cube theta. I just arranged it. You can arrange it anytime. Maybe you can take a common and then arrange it. So nothing wrong. I have arranged it and then taken out a common. You can even take out a common and then rearrange it. So how I've arranged is, see, you can see sine cube theta and you can see cos cube theta. So this is like a cubed and b cubed. So a will be sine theta, b will be cos theta. So 3a square b, 3 sine square theta cos theta, then 3a b square, 3 sine theta cos square theta. So arranged it in that order. So that's the next step. So this is the next step, rearranging the terms according to the way it happens in the identity. Then I've taken out a common. You can even take out a common and then arrange the terms. Then I've taken out a common. Okay, after taking a common, when you take out a common, that's it, we're done. You just have to show that this is in the form a cubed, a the whole cube. Then this one is b the whole cubed. Then this is 3a square b. See, 3a square b. And this is 3ab square. You just have to present it in that form. You can see when you simplify, you will get these terms. See, when you write it like this, 3a square b, 3 sine square theta cos theta, this one. And when you write it like this, 3ab square, 3 sine theta cos square theta, you can see it here. So m plus n, see here, this is m plus n. We're working m plus n only. M plus n is equal to a is common, and this whole thing is a plus b the whole cube. I told you the identity. So sine theta plus cos theta the whole cube. You can also write this as, you can see here, you can also write it as sine theta plus cos theta the whole cube, can also be written as cos theta plus sine theta the whole cube. So if you need further, if you see you need to write it as cos theta plus sine theta the whole cube, you can make that change. Next, find m minus n. Same procedure, children. Same procedure. Find m minus n. Okay, so m minus n, the signs will change. Then I've rearranged the terms, taken out a common, and then presented it in the form a cubed. See here, you cannot write sine cube theta first because it's minus a cubed. Minus a is not minus a cubed, minus a sine cube theta. So you cannot write that first. In the expression, A cos cubed theta is positive. A sine cubed theta is negative. So you have to write this here only. Minus A sine cubed theta. This is A cubed minus B cubed. This is A cubed. This is minus B cubed. And in the middle, you have minus 3A square B plus 3AB square. In the middle, you have minus 3. See, from the signs you can make out, children. From the signs you can make out. It's not difficult to rearrange. See, this is A cubed. Then where is minus? See, this is minus. So minus 3A square B. Then there's a plus. This is plus. So plus 3AB square minus B cube, minus B cube. From the signs itself, you can rearrange it. Tell you again, this is A cubed. Then this is minus B cubed, minus B cubed. Then the second term will be minus 3A square B, minus 3A square B, plus 3AB square. This has a plus sign. This one has a minus sign. So minus first, minus 3A square B, plus 3AB square, minus B cube. From using the signs, you can rearrange. Then take out A common. Then show that it's of this form. A cubed minus 3A square B plus 3AB square minus B cubed, which is nothing but A minus B the whole cubed. A minus B the whole cube. So cos theta minus sin theta the whole cube. See, so polynomials of last year is so important. So m minus n is equal to A into cos theta minus sin theta the whole cube. So now we found m plus n and m minus n. We found m plus n and m minus n. Now m plus n to the power 2 by 3, m minus n to the power 2 by 3. So you can see here, I've substituted m plus n and m minus n. I've substituted. This is m plus n. This is m minus n. Power 2 by 3, power 2 by 3. So when you have children, when you have a, b, the whole power 2 by 3, it means a to the power 2 by 3 into b to the power 2 by 3. Similarly, here you, and okay, sorry, let me tell you something else. So supposing you have a, b cubed to the power 2 by 3. Okay, it is a to the power 2 by 3 into b to the power, there's already power 3 into 2 by 3. So 3 and 3 will get cancelled. So you will get a to the power 2 by 3 into b square. So here also you can see this is m plus n to the power 2 by 3. So now you should apply the power 2 by 3 to all the terms inside the bracket. So there is a and this one cos theta plus sin theta the whole cube. So apply the power 2 by 3 to both. So what will you get? A to the power 2 by 3, a to the power 2 by 3 into this one. This one, it already has a power 3. So 3 into 2 by 3 into 2 by 3. There's already a power 3 there into 2 by 3. Multiply the powers. That's the rule of exponents. B square, if it is raised to the power 3 and again raised to the power 4, multiply all the powers. B to the power 2 into 3 into 4. When the base is raised to many powers, simply multiply the powers. So again in the next bracket, a to the power 2 by 3 and cos theta minus sin theta. There's already power 3 into 2 by 3. Multiply the powers. So now what will happen? This 3 and 3 will get cancelled. Here also this 3 and 3 will get cancelled. Now let's write what is left. Okay. And before that, you can also see a to the power 2 by 3 common. You can see here in the first bracket, we have a to the power 2 by 3. Here also we have a to the power 2 by 3. So that's common. A to the power 2 by 3 is common in both the brackets. So take it out. Take it out. So then what do you get? What do you get? You would have cancelled this 3 and 3. This 3 and 3. So in the bracket, you have cos theta plus sin theta the whole square. Cos theta plus sin theta the whole square. And here you will have cos theta minus sin theta the whole square. And use identity because it's already lengthy. Now, how many more steps? So it's already lengthy. So now use identity. A plus b the whole square plus a minus b the whole square is 2 of a square plus b square. Use this identity. So a to the power 2 by 3 as it is. And it becomes 2 of a, this one becomes 2 of a square plus b square. So 2 of cos theta the whole square. A is cos theta, b is sin theta. A is cos theta, b is sin theta. So a of, 2 of cos theta the whole square plus sin theta the whole square. A is cos theta, B is sin theta. So that's the next step. So cos theta the whole square is cos square theta, sin theta the whole square is sin square theta. So you'll get 2 into cos square theta plus sin square theta, which is 1. This is 1. 2 into 1, which is 2. And 2 into a to the power 2 by 3 is 2a to the power 2 by 3, which is the RHS. One thing I forgot to tell you is, so since here it is cos theta minus sin theta the whole cubed, here we take this as cos theta plus sin theta the whole cubed while substituting. We change it. See, at this point, you will not know that you should write it as a into cos theta plus sin theta the whole cube. If I say, okay, children, after this, you write it as a into cos theta plus sin theta the whole cube. So your question will be, how do you know that you have to write it like this? So we don't know, right? Yeah, even I don't know. At this point, how do I know? Even I don't know. So I leave it like this. A into sin theta plus cos theta the whole cube. But the next one, m minus n, we get a into cos theta minus sin theta the whole cube. Cos theta minus sin theta. So we'll take this as cos theta plus sin theta. So see here. We'll take this one as cos theta plus sin theta. Instead of sin theta plus cos theta. Both are the same. But since it's cos theta minus sin theta here, we have to take this as cos theta plus sin theta. Yes, children? Work out this. As you're working, when you encounter some problem, please get your doubts clarified there itself. 5 minutes. Class, use the emoji. Raise your hand. Ramnathan, Sashmin, Ananya, Rajarajeshwari, Kanishka, Shreyas, Murali, Harani, Sneha, Nandini, Hitesh, Pranav, Netra, Priyanka, and Tarun Murali. Very good, children. Very good. Yeah. Please ask me whatever your doubt it may be. Your doubt will help me to make the answer clear for the others. This note is just for us, okay? You don't have to write it. If this question appears in the exam, you don't have to write this one. This note is just for us to understand. You write it now in your notebook, but need not be presented when you write your exam in case this question happens. Children, I repeat, I've told you that, there is only one playlist link for one chapter. So students who miss a session can use the same playlist link. I've told this earlier. I need not share the recording of that particular class. Use the same link. One chapter has only one playlist link. So you already have the playlist link for trigonometry. Use the same link. All the meeting recordings will be uploaded there only. That playlist link will get updated. When I upload, that link will be updated. And these days I do it on the same day. I finish my work, I finish dinner, and mostly by 10:30, I upload the videos. So if you miss a session, the same day, around 10:30, you'll find the video, you'll find the meeting recording in the same playlist link. You don't have to request for the recording at all. Let me know if you need more time.
Yes, ma'am, we didn't complete.
Okay.
Completed, ma'am.
All right. What about the others? Done, children? Anybody wants me to wait?
No, no, no.
Okay. I'll let you know. Very good. Yeah. So there's a similar one. It's a similar one. So there is one small rule. Here, nothing can be simplified kind of. See here, a cos cube theta plus 3a sine square theta cos. It's already, this expression is already in, cos and sine. Here also this expression is already in cos and sine. Sometimes when the expressions are not in sine and cos, or you feel that the given expressions can be simplified further, please simplify and then you can prove the result. I'll tell you what I mean more clearly with this. Now see here, m is given to be cot theta plus tan theta. So let's just work and see if we can simplify this expression and get it in terms of sine and cos. Supposing you work and you feel, no, the given thing is simple, this is more complicated, then don't go with that. We'll just work and see what happens. Okay, we'll just see. So now what happens, m is equal to cot theta can be written as cos theta by sin theta, and this can be written as sin theta by cos theta. Okay, let's see what happens further. You can take sin theta cos theta as a common denominator. So you get cos square theta plus sin square theta. So m is equal to 1 by sin theta cos theta. Looks pretty simple, no? Like when you change cot and tan to sin and cos, we have a simpler version only. 1 by sin theta cos theta. Looks good. Let's check with this one. Secant theta minus cos theta. All right. So we can write secant theta as 1 by cos theta minus cos theta. We're trying to change other ratios to sin and cos. So secant is 1 by cos minus cos as it is. Don't write cos as 1 by secant. Our intention is to write the other ratios in terms of sin and cos. So n is equal to cos theta is a common denominator, 1 minus cos square theta. And we know that 1 minus cos square theta is sin square theta by cos theta. Looks good only. So we'll go ahead with these expressions for m and n. So what is that you'll have to remember? If the expressions given for m and n, okay. So here also we had expressions for m and n. We had expressions for m and n. But we did not simplify them because we thought nothing much can be done because the ratios are already in sin and cos. So we proceeded as the expressions were given. But here we just tried to simplify this because the ratios are not in sin and cos. Okay, so we try to change it to sin and cos and see what happens. And this looks simple. We'll proceed with this. We'll use these expressions for m and n. So I'll show you the answer slide. The rest of it is easy, children. The rest of it is easy. So what is that? You'll have to work m square n to the power 2 by 3. So you got a simpler expression for m square and into n. Then raise it to the power 2 by 3. Excuse me. And then again you'll have to work n square. That is m into n square. M into n square, the whole power 2 by 3, and subtract these two results. It's very simple. You can understand yourself. Any questions you can ask me? See here. I've simplified m, I've simplified n, and then I worked this one first. Then I worked this one. Then I've subtracted. And we need to get one as a result. Very important. Simple, very simple. I'll just get back, children. Please work this. Done, children? Finish writing?
No, ma'am.
Okay.
Ma'am,
Yeah. Yes, Shreyas?
ma'am, I have a doubt in that m square n by 2 by 3.
M square. Which one? M square?
Ma'am, n square n to the whole power 2 by 3 is equal to secant square theta.
You are right. This one. Okay, fine. So what is M? 1 by, see, we need to write M square. We need to write M square.
Ma'am,
What is M?
I can
Yeah.
understand that, ma'am, but what if we write secant square theta, let it remain as 1 by 1 by cos square theta itself, no, ma'am. Then m
1 by cos cube.
cos square theta.
It will be 1 by cos theta to the power 3 into 2 by 3. So 3 and 3 will get cancelled. So it will be 1 by cos square theta, which is secant square theta.
Ma'am, if we substitute 1 by cos square theta instead in m square and into 2 by 3, would we get the same answer?
No, please come again. In M square, what should you substitute?
Ma'am?
Yeah, tell me.
Ma'am, instead of secant square theta, what if we substitute 1 by
Where is secant square theta? In which step do you see secant square theta? This one is secant square theta here, huh?
yes, ma'am.
Okay, but no, I'm not getting your question actually. Till here you understood?
Ma'am, yes, ma'am. Ma'am, actually I understood the whole question, ma'am. But
Yeah,
what if instead of secant square theta, what if we write 1 by cos square theta and in mn square to the whole power 2 by 3 instead of tan square
Okay.
theta?
Okay, I get you. I'm getting you. Sorry. I took a while to understand. Yeah. Okay, now I get you. So you're asking me if this one, if you wrote it as 1 by cos square theta instead of this 1 by cos square theta, correct?
Yes, ma'am.
Okay. I got you. And this one as what? This one as
Sin
it is.
square theta by cos square theta.
Okay, this one you want to write as sin square theta by cos square theta, right?
Yes, ma'am.
Okay, fine. So now what will be the next step? 1 by cos square theta. You only tell me. We will get the answer is yes, you will get the answer. Yeah, now tell me. Minus
sin square theta by cos square theta.
by cos square theta. Then what's the common denominator?
Cos square theta.
Okay, then what do you have in the numerator?
1 minus sin square theta.
Yeah. What is the identity? We know that sin square
Sin
theta
square
plus
theta plus cos square theta is equal to 1.
1.
Yes, ma'am.
So what is 1 minus sin square theta?
Cos square theta.
Very good. Cos square theta divided by cos square theta, which is 1. All right?
Yeah, okay, ma'am. Thank you.
Yeah. Okay. Done, children?
Yes, ma'am.
Okay. So I told you that if possible, we have to simplify the expressions. So we're using these expressions for m and n. So substitute carefully. M square. So we'll work it in parts. This is the LHS. We'll work it in parts. We'll first work this and then work this. Okay. So it's just about being very careful. The working is very simple. M square. So write M and square it. Then there is n here, into. There's no sign, that means into. This is m square into, this is n. You can see here, this is n. This is n. N, this one. Then the whole thing is raised to the power 2 by 3. So whatever you've written, you should enclose the whole thing in a bracket. Whatever you've written, you should enclose the whole thing in a bracket and raise it to the power 2 by 3. You can see it here. The whole thing is raised to the power 2 by 3. So enclose the whole thing in a bracket and raise it to the power 2 by 3. That's the first step. Then you should apply now. Okay, so here you can find the product. So what is this 1 square 1? And what is sine theta, cos theta, the whole? Apply the power 2. We need to simplify that. It's squared. This one is squared. So we need to simplify this. So 1 square is 1. And sine theta, cos theta, the whole square is sine square theta, cos square theta. Like 1 by AB, the whole square is 1 by A square B square. 1 by A square B square. So 1 by sine square theta, cos square theta. So now this power 2 is gone. We've applied that power into sine square theta by cos theta. The whole power 2 by 3. The whole power 2 by 3. Now let's simplify inside the bracket. Sine square theta gets cancelled. So 1 by, like A square into A is A cubed. A square into A is A cubed. So cos cubed theta. The whole power 2 by 3. So 1 by cos cube theta secant cube theta. 1 by cos cube theta secant cube theta. Because 1 by cos theta is secant theta. So 1 by cos cube theta will be secant cube theta. The whole power 2 by 3. Now here secant theta is raised to the power 3. And there's another power 2 by 3. So multiply the powers. Secant theta, the whole power 3 into 2 by 3. Multiply the powers. The power is 3 here and the power is 2 by 3 here. So it will be secant theta, the whole power 3 into 2 by 3. So 3 and 3 gets cancelled. So secant theta, the whole square, which is secant square theta. Secant square theta. So the value of this one is secant square theta. Now again like that, work the next one. Mn square, the whole power 2 by 3. This is m. This is n square. The whole thing is raised to the power 2 by 3. So use a square bracket, enclose the whole thing and raise it to the power 2 by 3. Then this one comes as it is. Now here square, apply the square to the numerator and the denominator. Apply the square to the numerator and the denominator. So when you square this, it's already a square. Again, when you square it, a to the power 4. So sine theta to the power 4. Sine theta to the power 4. Because there's a square here and it's again squared. So 2 to the 4. Sine theta to the power 4. Cos theta and it's squared. So cos square theta. The whole power 2 by 3. The whole thing is raised to the power 2 by 3. So what will happen here? This is like a to the power 4. This is like a to the power 4. This is like a. So this will become a cubed. There's a here and there's a to the power 4 here. So it will become a cubed. So sine cubed theta on simplifying. Sine cubed theta. See here, this sine theta and this one. So what remains is sine cubed theta. Like a to the power 4 by a is a cubed. Okay, so you get sine cube theta by cos theta into cos square theta is cos cubed theta. A into a square is a cubed. Cos theta into cos square theta. A into a square is a cubed. The whole power 2 by 3. Now sine cube theta by cos cube theta is tan cube theta. The whole power 2 by 3. So there's power 3 here, power 2 by 3 here. So 3 into 2 by 3. 3 cancels. Tan theta the whole square, which is tan square theta. Now we need to find this minus this one. So which means secant square theta minus tan square theta. That by the identity is 1, which is the RHS. It's a very simple one. Very, very simple one. Maybe the powers and all that, you know, they look intimidating, but it's actually very simple. So there's a lot of exponents here. So remember, when the expressions can be simplified, please simplify and then use the simplified expressions for m and n. So if cos theta plus sin theta is equal to root 2 cos theta, show that cos theta minus sin theta is root 2 sin theta. Now, can you, now we are given the value of cos theta plus sin theta, and we are asked to find, or we are asked to show that cos theta minus sin theta is equal to root 2 sin theta. Can you connect the expressions using any identity here? Show that, meaning you'll have to prove that cos theta minus sin theta is root 2 sin theta. Okay, let me stress on cos theta plus sin theta, cos theta minus sin theta. Does that remind you of some identity?
A plus B into A minus B is equal to A square and minus B square.
Okay, well, yeah, very good. Okay. But something else which we have learned this year, that is, we need to connect these expressions, A plus B and A minus B, using an identity. So this one can be worked using the identity A plus B the whole square plus A minus B the whole square is equal to 2 of A square plus B square. So this is an identity that will connect, you know, the expressions given here. Now see here. So what is A plus B the whole square? It's cos theta plus sin theta the whole square. Cos theta plus sin theta the whole square. What is A minus B the whole square? Cos theta minus sin. See here, we are just using this identity and we are substituting A with cos theta and B with sin theta. That's all. We are taking up an identity relevant to the situation. So the identity is A plus B the whole square plus A minus B the whole square is equal to 2 of A square plus B square. Now in this identity, instead of A, we are going to use cos theta, and for B, we are going to use sin theta. So rewrite the identity using cos theta and sin theta is equal to 2 of cos square theta plus sin square theta. Yes or no? Now cos theta plus sin theta the whole square. So we know that cos theta plus sin theta is root 2 cos theta. Root 2 cos theta the whole square plus. This is what we have to find or prove. So write this as it is. Cos theta minus sin theta is what we have to get. So write that as it is. We have to find, we'll have to show that cos theta minus sin theta is equal to root 2 sin theta. So write that as it is equal to 2 into 1, because cos square theta plus sin square theta is 1. Now this is 2 cos square theta plus cos theta minus sin theta the whole square is equal to 2. Now transpose, because we have to find the value of cos theta minus sin theta. So we'll have this alone on one side and we'll transpose minus 2 cos square theta. Now at least tell me what after this, children. What, children, after this? What's a golden rule?
Taking common.
Yeah, very good. That was from Ramnathan, right?
Yes, ma'am.
Very good, very good. Yeah, Ramnathan, tell me 2 into 2 open bracket.
1 minus
1 minus cos.
1 minus cos square theta. Now, what is 1 minus cos square theta, children?
Square theta.
sin square theta.
Yeah, so it is 2 sin square theta. It is 2 sin square theta. Cos theta minus sin theta, the whole square is 2 sin theta. 2 sin square theta. So cos theta minus sin theta will be the square root of 2 sin square theta, which is equal to root 2 sin theta. Sin square theta will come out of the square root of sin theta. Sin square theta will come out of the square root of sin theta, while 2 remains under the square root. So root 2 sin theta. Now, don't worry, I'll show you the answer slide. Now, you have to decide between which identity to use. Now, we have a plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. And we also have another one, a plus b the whole square minus a minus b the whole square is equal to 4ab, is equal to 4ab. Is equal to 4ab, this one. We choose to use this one because 2 of a square plus b square. A is cos theta, b is sin theta. So a square plus b square will be cos square theta plus sin square theta. We know is 1. We know is 1. So for that convenience, we use this identity. So how does the working go? We first make use of this algebraic identity, a plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. We first write this identity. Now we'll say let a be cos theta and let b be sin theta. And we rewrite this identity using cos theta and sin theta. So cos theta plus sin theta the whole square plus cos theta minus sin theta the whole square is equal to 2 of cos square theta plus sin square theta. We'll just 2 into 1, 2. So for this we substitute. For this we substitute root 2 cos theta, the whole square. And this is what we have to find. So write it as it is. You can't substitute that with root 2 sin theta. That's what we'll have to prove. You can't substitute this. Just write this as it is equal to 2. Then transposing and all that, you get the result. I'll show you the answer. Please write down. Children, since it's time, I think you can take a screenshot and complete it. You can see here I've written the identity, exactly what I explained now. Identity and substituting. We're taking A as cos theta and B as sin theta. We rewrite the identity and exactly what I explained. Yes, children, please take a screenshot. Done, children? Took a screenshot? Please complete this. Finish dinner and complete it, children. Or if you've already finished your dinner, please complete this after the class. Yeah. All right, children. So that was it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you.
Thank you. Thank you, children. Good night. Thank you, children. Good night.
Thank you, ma'am.
Thank you. Good night.